So, how are we doing? Good. Right on. All right. Okay. Welcome to the third session. We did most of our workshop over the first two sessions. It was sort of a simple design. Is it a little quiet or? That'll do it. Ooh, that's loud.
You can lower it.
Yeah. Okay, test 1, 2. Yeah, that should work. Okay, welcome back everyone. Second workshop, or third workshop I should say. We covered most of the design process in the first two workshops, and this workshop I'm just going to finish up with more of the how to export your PCB, send it to a manufacturer, and all of that. One thing I neglected to mention the other day as we were designing is sort of a best practice guide on how to draw the traces on your PCB, how to lay it out. Of course, it's a guide, it's not, law. You don't have to follow this to the T, but it does kind of help you create a consistent board, and with consistency you get success most times. And I believe you guys did get this in an email, so you can open that up and look through it as you see fit. One of the key topics that I want to go over before we get into everything else is trace bends, the 90-degree angles, as well as trace junctions. So within the hobby space and just in engineering in general, there's going to be guys who will say 45-degree angles are the only way and anything other than that is incorrect. It entirely comes down to the application. In most use cases, the 45-degree miters are usually what you go with, but they're sort of an artifact of older softwares where for computational simplicity, it's a lot easier to do a 45-degree angle versus an arch. But yeah, and then if you think about it just geometrically, a 90-degree angle, such as in the A here, the only reason you wouldn't go with that is in an application where you want the trace to be shorter. Pythagoras theorem, the 45-degree angle has a shorter path than the 90-degree. But if you have a design simple, such as maybe our circuit that we made the other day, a 45 or a 90-degree angle is completely okay. There's no issue there. And then for faster applications, once you get into higher frequencies, the 90-degree angle could actually cause problems with just the characteristics of the signal. So going with the 45-degree or even doing a rounded arch is the way to go. So yeah, and then trace junctions. Normally we try to avoid acute angles just because of that the sharp little pit there tends to kind of hold on to the etchant, the acid, and so you'd end up with an inconsistent etch there. That's mainly in the older days. Nowadays you could get away with it. But for signal integrity as well, the acute angle is not recommended. So normally in industry we'd use a T junction, or a mitered T is usually better. And then between B and C here, the mitered and the Y junction, those two are sort of what we would use. I prefer to use the Y, but it is entirely preference. What else? And then once you get into more complicated designs, digital designs, you might need decoupling capacitors. It's good to keep those close to the IC power pins. I won't go into that today just because it is a little bit more of an in-depth topic. But I do cover it here, power distribution and thermal relief, reflow considerations, all of that. And then in addition to that, if you scroll to the bottom, I'll have links to web pages that cover more topics. So you can go down whichever rabbit hole you want to. Yeah, so that's something I missed yesterday, but it is there. Oh, yeah, and then this little table here is for trace width and the currents going through it. So IPC recommended trace widths for various temperatures and currents. So yeah. Yesterday I briefly went over exporting and viewing Gerber files just for those who wouldn't make it to today's session, but today we'll jump right into this. So if we go to our project, of course I don't have it opened. When you open a project as well, you could open up just the PCB file or just the schematic file. The issue with that though is if you open up just a PCB file and you go to update, actually I could probably show you here, it won't have that update from schematic button just because you opened up only the PCB. You didn't open up the whole project, right? So up here you can't see the little icon that we used to update our design. So if I go here and open up the project and then open up the PCB design, then you'll see this guy here, which was missing. So that's a small nuance with the software. Okay, so I'm going to, this is our finished design. I believe I sent this to Tomi to send the email to all of you if you guys got a little stock class session. This is a complete design. Run the DRC just to make sure everything's good. Wow, there we go. Good, no errors, no warnings. Okay, so to export files, we will export what's called a Gerber file, and you can think of a Gerber as an image of each layer. So for instance, if I was to hide every other layer and only show the front copper, the Gerber would have essentially an image of that the manufacturer can then use to etch the PCB and get it ready for you. So to get these Gerbers, what you would do is you'd first run the DRC, make sure your design is compliant with all of your constraints. And then after that, you can go to fabrication outputs. And you've got plenty of options. Some manufacturers do accept different outputs, but most of the common ones, such as the Chinese manufacturers, or one or two, I think, in the United States, they all will take Gerber files. So to create a Gerber file, you go there, click on this, and you can choose all of the layers you want to export. And in here, I will choose to export the front copper, the back copper, our silk screens, the solder mask, and our edge cuts. And then everything else I could just leave unselected. If you select everything, you'll have a lot more files because each of these gets generated into a file, a Gerber file. So I like to keep it minimal and keep it to what I'm using. And then another key one is output directory. Since Gerber files, when it generates them, it'll generate a file for every layer. I like to define a folder to put them in instead of have them go to the root directory of my project. At the start, I used to do that, and it was always a pain to have to grab all those files and put them in a folder afterwards. So to do that, I just open up this little folder icon, and you get your operating system's File Explorer prompt, which you can create a folder, select that folder, and you'll have it. In this case, I created a Gerbers folder, so that is what I have, and then I'll just do select folder. And yes, I want it to be relative. So there's that. We have some general options. Each of these has their own purpose. In this case, we don't need to touch them. The defaults are perfectly fine for most use cases. Just make sure your coordinate format is the way you want it. Some manufacturers might use an older system. They'll define that in their website, but all the defaults should be good as is. And then you can run the DRC in this window as well, but in this case, all we have to do is plot. And as you can see in the output here, we can see all of the files it created. It created the back, the front, copper, silkscreen, mask, and edge cuts. And it created a .gbr file. That is our Gerber file, as well as a Gerber job file, which sort of tells the manufacturer what each of these files do. Now that's all of the layers. However, the manufacturer still doesn't know where to drill our holes. So to do that, we need to create drill files. And we can output them to the same folder. There's different formats for them. Exelon is the default that most of the CAM softwares, all the software that people use to generate CNC toolpaths, use. So we'll leave it on the default settings, and we can just hit generate, and it'll generate two path files, two drill files. And yeah, and that's all there is to it. So with all those files generated, we can go back to our project folder, and in Gerber's, I created a zip folder yesterday, so I'll delete that. In the Gerber's folder, we'll see all of our outputs. Now, this is a really easy part. All we have to do to send it to the manufacturer is put them in a zip. I use 7-zip. Everyone has their own preference to what software they use to compress files. All you have to do is find a way to create a zip file and just put that folder in the zip file. And now that we have that, we've got our zip. And then from there, we can go to our manufacturer of preference. I tend to go with PCB way, not sponsored. And then on their main page, it'll have an instant quote. I just go to this tab, and from here, I am able to upload my Gerber files. So I think you can manually upload each one, or it does prefer compressed medium. So with that, you can just select your Gerbers.zip and open it in there. And with that, it'll auto-detect your board, your layout. Sometimes it gives you a preview. Actually, let's try JLC PCB. I think that one gives you a preview sometimes. So different manufacturers, but they work fairly similarly. Add Gerber. Document. TTL. Gerbers.zip. Open. And then. So just an example between two manufacturers. The process is pretty much exactly the same. There we go. This guy gives us our preview. So as you can see, it previews the board for you so you can see what it is you're actually sending to them. And the options each manufacturer has might vary between, say, PCBWay and JLC PCB. But generally, it all falls under a general category. You can select the dimension of the board if it doesn't auto-detect it. You can select how many of these boards you want to create. I didn't realize JLC allowed you to create so many. But 75 or 10, depending on whether you're prototyping or doing a small launch of like a product. Yeah, and you can also choose the product type. If you choose aerospace or medical, they'll make sure to test it under some more stringent methods to ensure it's working. And with that, it also comes with an extra cost, I think. But industrial consumer is usually what a project will fall under. A lot of these options are auto-selected just from us uploading our Gerber, but if you want a thin PCB, you can choose to have it thinner, or the general standard is 1.6 millimeters. You can choose the color of your solder mask, so if you want a red PCB, or a green is the most common, but you could even have black. I like that. It's a very nice color with white silkscreen. And then you could choose the material of your substrate. In our case, we designed our board with FR4, so we'll stick with that, but there's a ton of different substrate materials that you choose, and it depends on your use case, what it is you're designing, and you would know which substrate to use before you even start the project. Surface finish, that would be what the pads are plated with. So if you ever look at a PCB and you see how the copper pads are actually silver looking, that's usually because they have a silver solder sort of finish, which would be the lead-free HASL. If you want a cheaper option, you can have it with lead. Just don't eat right after handling these boards. Wash your hands. You choose your copper weight, so the thickness of the copper layer. In our case, we're doing 1 ounce. Via coverings. There's different ways to cover vias, or holes that connect bottom and top traces. Usually I'll leave them as tented, but you can also have them untented, where the solder mask doesn't go over top of them. Or you could have it so they plug it with solder mask just completely all the way through. Again, this is sort of more nuanced. You don't need to worry about it with a simple project. But yeah, you've got a lot of different options that you can always read through. I think JLC kind of goes through, if you have any question on which option to go with, they'll have a little short excerpt on what each thing does. So yeah. And then once you're happy with your options, all you have to do is save to cart and submit the design for manufacture. Now, going back to JLC, they also have a similar sort of ordering system. Different surface finishes, via processes, copper thicknesses, and so on. Yeah, and if you're ever doing a project and you order a PCB, if you order in a low quantity, such as 5 or 10, most cases the PCB is half the cost of the shipping. Shipping will be a little bit more pricey. Actually, in this case, yeah, the PCB is $5 while the shipping is $22. So that's a typical outcome, especially if you choose Canada. Boom. Let's see how that goes. Yeah, it's about the same. So shipping will get you, but if you order a lot of them, you can sort of be a bit more economical, such as 25. I get 25 boards for about $50, which is fairly good, especially for the quality. Yeah. So that's ordering PCBs. I do have another sort of supplemental document on ordering the PCBs, and sort of more in detail on what each option means, and also ordering parts. Actually, I have ordering parts in here too. And yeah, it goes over just the various options and what each option does. So give that a read if you would like. There is, if you ever want to support North American companies, there is Oshpark based in the United States. They are a little bit more expensive, but it's North American, so there is that. And then all of their PCBs have the purple silk screen, so yeah, that's cool. And also, if you're ever having a hard time finding manufacturer tolerances when you're designing a board, I do have links to each of the manufacturer's tolerances page. So, yeah. Now, that is covered. I do want to go over what a Gerber file actually looks like. Because KiCad has a nice tool to allow us to view our Gerber files. So I'm going to close out of this, go to my project. If you're ever curious, or say there's an issue with a Gerber file that you didn't know of until you started to order your boards, you can always go to the Gerber viewer here, And you can, it looks similar to the PCB editor. However, if you go to File and you open Gerber plot files. If you open a Gerber file here, so say I want to open the front copper. Let's take a look at what that looks like on the Gerber file. There we go. So that's what the Gerber file looks like. And this is what the manufacturer sees. Essentially, this is, everywhere you see red will be covered by a mask, such as ink or photoresist. And then anywhere you don't see red will be exposed. And what they'll do is they'll put it in a bath of acid, and that acid will eat away at the copper to leave you with your traces. And yeah, and I think you can open up multiple, open files. If I highlight all of them, I think it'll open all of them. Yeah, you can't open up a job file. That makes sense. But as you can see here, you've got all your layers, and I can hide all of the ones I don't want to see. But say I want to see what the back looks like, I will look at the back copper. And then you've got, of course, your front copper, which we saw earlier. So yeah, this is a good way to verify your design, make sure you're not missing anything. Yeah. Now, I think that pretty much covers most of this workshop. I'm available the whole time here for questions. Or if any of you want to know something, just put up your hand and we can go over it as a group. Yeah. And regarding the soldering portion of the workshop, I know I was asked by a few of you. We're waiting for the boards that we ordered to come in, and once those come in, we'll book a time that works. And I think we'll try and book a lab with soldering irons to kind of get everyone together and create the boards. And those, I believe, will look like this, I think. So this is what we ordered. It's the same circuit, just I gave it a lot more time to figure out the layout, make it look pretty. But yeah, so there is that. All right. And that's the end there, but I'm here for Q&A, and I greatly suggest if you have any questions, do ask, because I like talking about this stuff.